All right, footings and slabs. So part 3.2.1, compliance with acceptable construction practice for footings and slabs provides that the footing is on a class A, S, M, MD, H or HD site. It doesn't say anything about P, does it? So this deemed to satisfy is for nice, predictable site classification. Anything outside of that, it has to be an alternative solution the engineer comes up with in consultation with the geotechnical analysis. It also has to be a slab that's not more than 30 metres long, and it has to contain permanent joints or construction joints. Oh, sorry, that they're not used. So again, not so much up here. And that it has to be supported by a footing that does not contain more than 2 trafficable floors or a wall height exceeding 8 metres, excluding any gable. And the footing does not support more than 1 concrete slab, or the building does not include wing walls or masonry arches, single leaf earth or stone masonry walls not exceeding 3 metres in height, and that the site is considered to be normal and not located in an alpine area. So there are a whole bunch of things that you can't use these deemed to satisfy conditions for. So I just want you to be aware of that. That's generally the rule up here, so it's not really a huge issue. We just simply use an engineered solution. It's a part of the normal process that an engineer checks our work before it goes to a permit to build. They give us a stamp called a Section 40. So they check the design. Is it compliant in accordance with AS 1170, which is the loads standard that I keep mentioning that we'll cover in the 4005 unit. They stamp it and check it and make sure that it will work under cyclonic conditions for the soil classification that it's on and for the loads and intended use. And then that'll go to the certifier and they'll let you build it. And then they'll keep inspecting it. Sometimes the certifier can inspect the engineer's work, but normally the engineer will have to come on site and check and make sure that the reinforcing is correct, the right size, in the right place for the extent that it needs to be in. They'll check that the concrete is the right strength and that it's been allowed to cure for the right amount of time so it can do its structural work. And they'll make sure that the timber or steel is the strength that it needs to be to achieve what he said was going to be compliant with AS 1170. And then at the end, before you're given a permit to occupy, they'll give you another Section 40 for the construction, and that will go to the certifier. And then they'll say, okay, it's fine to move into, it's safe. So that's an alternative solution. Correct me if I'm wrong, Sandra. Does that sound right to you?
Yeah.
Yep. Sorry. Yeah. So it's pretty hard to meet the deemed to satisfy requirements in the NCC here locally because of the situation that we're in with the termites and the cyclones and the soil and the sun and everything. What I mostly want to look at, and this is quite a good diagram, when you've got when you've got floors that change direction or might change heights, it's just a good diagram of how you might manage that with reinforcing. These dark lines are the reinforcing. So it's a pretty good example. It's just for interest's sake. I just was passing by and thought, oh yeah, that's interesting. So don't need to take a note. We are not changing directions with our slab, and an engineer would have to design this for us anyway, but just be aware.
So we just noted that.
Yes, yeah. So in the report you can put that you'll get a Section 40 certificate for design to attain the permit to build, and then you'll require a Section 40 for construction to get a permit to occupy.
So when you're drafting and you want to draw a slab in, you would draw a fairly standard slab on your section, and you would, just draw your ground floor on your floor plan, and then you would send that off to an engineer. The engineer will want to see a copy of the architectural drawings, and he then will compile a set of structural drawings that reflect what you've designed, but he will put in the reinforcing where it needs to go. He'll tell you the size of the footing that needs to be there. If it's just an edge beam on the edge of the slab that Lisa's shown there.
Yeah, we'll go into that in a second. Yeah.
And so the engineer will tell you either how to edit your drawings, or he'll do another set of drawings that are just a set of structural drawings that detail all of that.
So where we,
for you to design the thickness of a slab, or the height of a footing, or where the reinforcing should
even the type of slab, there's a few types, you know. We're going to show the finishes because the engineer is not interested in that. So the type of aesthetic finish on the raw concrete that we might want, or an applied finish that we might have, tiles or even concrete paint, or it might be polished, or it might be vinyl, who knows. Skirting, drainage, levels, and then the engineer helps us finish it off structurally. So here's our clause about vapour barriers. So make a note on your drawings and your report, NCC 3.2.2.6 vapour barriers. This is the damp-proof membrane that we've mentioned a few times now that goes down between the slab and the foundation, which is moisture content rich. A vapour barrier must be installed under slab-on-ground construction for all Class 1 buildings and for Class 10 buildings where the slab is continuous with the slab of a Class 1 building as follows. So if you've got a separate slab for a carport or a garage, a Class 10 building, and it's not continuous and connected with the rest, you don't have to damp-proof course that one. But remember, if you want to build that in later and make that part of the habitable space, the Class 1, you would have to have put it under there in the first place. So a lot of builders will put it down just in case, but it's a case-by-case basis. That's just a design intent. If you've got a separation and there's a foam expansion membrane between the two slabs, that's not continuous. You've got carport or garage, and then you've got living area. But if you've just got Class 1, damp-proof membrane everywhere.
But if I was building a shed, for myself or anyone else, for the cost of a damp-proof membrane, a piece of
put it down
under the slab, I would put it in every single time.
Just do it.
Nobody wants rising damp in their shed, really.
Nobody wants it anyway, yep.
Counted as coating? Would be counted as a coating?
With the plastic.
Not that I know of, no. Yeah. You mean like the bituminous coating underneath the bottom plate of the steel, between the steel and the slab?
Just in researching our materials.
Oh, the coatings, no, yeah, you're right, no. But if you're talking about concrete, you could mention it in there, I suppose, yeah. Yes. Still there.
The expansion gap.
Yep.
From the house to carport.
Yep.
So that actually divides the two slabs. So I was assuming
You put the plastic up and then build the carport slab if you were going to keep that without plastic.
Yeah, because I was assuming that plastic was underneath that slab as well.
It can be, like Sandra said. You're mad if you don't. But often carport and garage slabs are poured right at the end of the build, because often those slabs don't get a topper, they don't get a surface covering, they don't get made to look nice, and the construction process is quite a dirty process. So if you have concrete laid that is going to be left as just not raw, but sealed concrete, it'll get splatters and mess and dirt and everything all over it. So you pour that as late in the build as you can. So the main concrete will have finished, the plastic will be there, you can either lay more or not.
So if they didn't leave a tail
to overlap, because it can't just meet up, it's got to overlap and tape.
So when they poured the next one, so if they overlapped it and then poured it,
then it's all got,
which I'm assuming in the flows.
You would, perhaps,
What would you have to do? Dig up a strip and pin it in?
No, you just leave the tail out, and then when you pour the slab at the end, you overlap 600 and tape it.
Yeah, but what I'm saying is, if they did it, would you have to dig a hole in there?
Oh, would you even? Yes, I suppose you would have to dig, yes.
If you're gunning flows.
Yes, or you build a top slab and put the plastic underneath that.
If you dig down far enough at the side of the
you can find it.
You should be able to see if there's a membrane underneath it.
So the vapour sorry, David, No, this is mandatory for Class 1 buildings. It's not just so for Class 1, It's required. So our laundry is class 1. It's not habitable, but it's still class 1. So you definitely want the damp-proof membrane under the laundry as a minimum.
But we're recommending also...
I think just the laundry for us. Yeah. It's a dangerous game because people do build in underneath elevated houses, but the brief does not ask for that. You could perhaps highlight that in your report as something to be considered by the client. Do they think in the very near future or in the very far future they might build in that downstairs area? They've got the height because we're giving them plenty of room, so there's no restriction there. They may. We would perhaps recommend they put the damp-proof membrane under the carport slab. Problem with that is carport slabs aren't always built strong enough to support structural walls. So it does have a knock-on effect as you might have to make bigger footings and stronger concrete for the future that may never come. So it's a decision that the client would have to make.
But isn't... Yeah,
I've created a monster. Sorry?
Yeah, I think I didn't put it in a containment area in the day, so...
Yeah, but that's just an open, it's all open, shaded. I mean, it's an outdoor setting. So a carport slab is the same thickness, but the footings where the walls might go is not the same. It's not too bad for infill. If you've just got framing infill, maybe the carport footing might be enough. All right. So a vapour barrier must be a minimum of 2.2 millimetres nominal thickness polyethylene film and medium impact resistant. It's not much good if there's a hole in it. So it needs to be able to withstand medium impact. Got some pictures that I'm hoping I'll be able to show you of it in place. So you dig the holes where the footings will go, you put the plastic down, and then you bring little chairs in, little plastic chairs that the reinforcing sits on, because you don't want the steel reinforcing sitting right on top of the plastic before you pour the concrete. Where's my chair? Oh yes, thank you. So this is a chair, and the reinforcing bars sit in it. It might be a big fabric mesh, which we'll get to, and it just sits in there, and this sits on top of the plastic. So it needs to be able to cope with a little bit of movement. People walk on it in between the reinforcing, you know, setting these all things up and everything. So you don't want to... You've probably seen a few of those? Yeah, you probably have too, Nick, have you? So you don't want it to be easily torn. So medium impact resistant.
So just on the easily torn, so underneath that, like, so when you're preparing the ground, you might bring in some fill underneath, but then on top of the fill you need to put some sand, and then the damp-proof course goes on top of the sand, because obviously if the fill is rough and it's got some sharp edges in it, that can also puncture your damp-proof membrane. So the top layer has got to be 50 ml of sand, and then you put the damp-proof course on top of that. Put your chairs on, you lay out your reinforcing, and then you pour your slab over that. But you must protect the damp-proof course.
And then it's determined in accordance with some criteria, AS 2870, and be branded continuously, so it'll have stamps on it, that it's AS 2870 concrete underlay 0.2 millimetre medium impact resistant. So it's actually got stamps on it, it's got writing on it. It's usually orange. Yeah. It must be installed with a lap not less than 200 at all joints. I was saying 600, I don't know where I got that from, sorry, 200. And then tape or seal with a close fitting sleeve around all surface penetrations. So you have pipes that come up there underneath in the sand or in the foundation, and then they pop up through the slab. So moisture can climb in a capillary action if there's a lot of inundation underneath the ground. It can climb up through and up through the penetration, so you can have a collar around that. And it does double duty for termites as well. So you have like a little rubber collar around the pipework before you pour the slab, and that just stops the water from getting up where you've had to cut a hole in the vapour barrier to put the pipework up through. So for drainage and floor and waste and shower and toilet drains to go down and out. So the slab gets poured over the top of that pipework. Has to be fully sealed where punctured, unless for surface penetrations with additional polyethylene film and tape. So if you're walking around in high heels on site and you make a hole, you have to fix it. The vapour barrier must be placed beneath the slab so that the bottom surface of the slab is entirely underlaid and extends under edge beams to finish at ground level in accordance with figure 3.2.2.3.
That's your problem, Paul, or it never needs to finish at ground level. There's a great diagram there.
Yep, here it is here. So then you've got a little bit of an idea of where it sits. Now, this little bit here is a funny, so we are looking at a footing and a floor slab together. You don't always have to pour them together, but that's what we're looking at right here. So sometimes you just have a beam, an edge beam, or a footing that is long and thin, and there's no floor. So underneath our rear wall, I'm pointing to nowhere here, but our rear wall at the back of the property, there might be a separate beam underneath that that's not connected to the carport slab, just say. So it would just be a square. In this instance, we're looking at the floor and the footing combined in one. This dot here represents where the vapour barrier needs to go, and then the 50mm sand bed that Sandra was talking about would follow along underneath there, and then the normal soil would be underneath the rest. I can just add it to my diagram. So we're not, no, you're right. So we've got our damp-proof membrane here. I'm just using a contrasting colour without the dashes, but it's usually dashed. And then we've got little dots to represent sand, and that's 50mm thick, and it's compacted, it's not just loose sand, so you have to get out with the whacker-packer.
The idea of the sand is to leave a space for the tree roots to follow.
Ah, thanks, yeah. And then you've got your soil.
Well, that's what happened when we dug up the floor.
All the way around.
Underneath the slab of the house, because that followed the sand.
So note carefully the different drafting techniques to show all of those different build-ups for the site preparation. You've got the hatch there showing the earth or the fill that you would bring in. You show the sand as just as a dot, and then the damp-proof membrane. In drafting, we never just use one line to show something. So we always use two lines. The exception to that is where you're showing a damp-proof course or a vapour barrier, and you show that in a heavy, dashed black line. It needs to be heavy because it's very faint. It's one of those elements that just gets missed. It's so faint, it's like 2mm. Or 0.2, isn't it? So 0.2mm thick. So, you know, we can't show two lines.
Not to scale, yeah.
Thing. We show it in a heavy dashed dark line. So when you look at a drawing like that, everybody knows that that dashed line is representing something underneath the slab there. And of course you can label it.
There's a couple of different rebated edge alternatives, and the masonry veneer that we were talking about yesterday. So their wall construction isn't necessarily accurate to what we might be doing in our laundry, but the process is reasonably similar. So you could use this in your report to illustrate where the damp-proof membrane needs to go if you wanted to. Or you could re-sketch.
Detail is the one Lisa has drawn. So we normally don't normally do this little.
No, we don't.
On our edge, we just have a square edge like this on our edge beam, and then our 200mm block work or our post big post or construction just comes straight off that, and our cladding is right here. Our standard.
Yeah, they're good for the doors.
Really
oh, okay.
But our standard normal dwelling house.
Yeah. Take a break, 15 minutes. I'm going to go live on YouTube. Yeah, it's like it never even happened. Like that one hand clapping thing.
Like the tree falling.
There you go.
We can hear it.
Part 3.2.3, concrete and reinforcing. Part 3.2.3.1, concrete. Concrete must comply with the following. Concrete must be manufactured to comply with AS 3600, another Australian standard in it for you. We're just throwing them out thick and fast. AS 3600 is for concrete. There are a few others, long slab concrete forms, small concrete forms have their own standard. This is the general one for the concrete itself, not the form that it's in. It must have a strength at 28 days, that curing time, 28 days is the minimum. They check it at 7 and 14 and 28 for bigger projects, but it must have a strength at 28 days of not less than 20 MPa. It's often written as an N20 on the drawings, grade. So just mentally bookmark that for a minute until we finish these clauses, and then I'll explain that in a minute. It must have a 20mm maximum nominal aggregate size. So we talked a bit about materials yesterday, and we mentioned concrete, and Nick suggested cement might be a material. But what I said was that the actual finished product is concrete, and cement is an ingredient in concrete. The other one is sand, and the third is aggregate. So aggregate is just rocks. Gravel, yeah. So road base, basically just blue, sharp rocks, little ones. Now, the makeup of what that aggregate needs to look like changes depending on the performance of the concrete itself. So the look of the finished product or the way the product needs to be able to move, because if it's full of rocks, it's very hard to move. So there's liquidy parts of concrete and then there's the rocky parts of concrete. But cement, the part that makes up the glue that sets hard, is expensive. So if you don't have to fill it all with cement, you can make a little less expensive concrete if you use rocks in their place. But you have to be careful with how much you use. And what they're suggesting is that not only does NCC deemed satisfied concrete have to have a minimum strength of 20 MPa, the aggregate can't be any greater in size than 20 millimetres. So it has to be a reasonably medium size. You can get very small aggregate and you can get very large aggregate. They just want a nice, regular 20 mil size.
Again, this is something that we'll get from concrete.
The batch plant, so you specify it and it comes in. Yep. And it has to have a nominal 100 millimetre slump. What's a slump, they say? Does anybody know what a slump is?
When we check the concrete level, we just measure the slump test.
Correct. Very nice.
What is a slump test?
Slump test, the water ratio of the concrete, and measure the road instead of putting the concrete instead of the slump base, and take off the slump blade, check the level.
Take off somewhat.
The base, and check the level. If it is less than 100, make use.
Too much water in the mix, yeah. And if it
Precisely.
doesn't slump at all, there's not enough water in the mix.
So concrete, when it comes out of a concrete truck, has to be moved into place. So it's plastic. It moves around. If it's too wet, it's too plastic. And if it's not wet enough, it's not plastic enough. So there's a fine line between making a concrete slab that is compliant with all these requirements and not making a slab compliant with all these requirements. And a way to check that it has the right aggregate size and MPa is to do a slump test and to make sure there's not too much water in it, because if it's too plastic, it's probably not going to cure sufficiently. And there are other factors with regards to how that curing happens. If you let it get too hot, it can crack and things like that, which is a whole other issue. This is a picture of what a slump test might look like at the beginning. It's a big steel cone, and you can turn it upside down and fill it with concrete and then make it like a sandcastle, and it has a measuring gauge. And then you take the top off, you take the mould away, and see what the concrete does when you take the support away. And if it slumps greater than 100 millimetres, so if you take the mould away and it ends up going, bleh, it's too wet, and you can't use it, and you have to discard that truck of concrete. If when you take the top away, it doesn't move at all, it's not plastic enough, and you're not going to be able to work it into the corners, and it has to go. So concrete, as soon as you mix it, as soon as you put the cement in connection with water, it starts to react immediately. That's why concrete trucks are always turning. So it takes too long from the batching plant to the site, and you make the concrete truck wait too long, they might be tempted to put some water in there to keep it moving as it's starting to go off, and then you end up with a slump test that doesn't look very good. So it's important that the inspector is on site to accept or reject concrete that comes out of each truck. There's lots of other chemicals you can put in, like in the old days they used to put just detergent in there to make it more plastic. Again, that's got to be a known additive, they're special, so that'll come up in your research. You can add them, but it has to be accounted for in the engineering. So this is a slump. It must have a nominal 100 millimetre slump. You don't always see the actual cone, you often just see a pile of concrete on the ground. And that's often enough, yeah. Now ideally what should be captured is a sample of the concrete, so probably maybe 3 samples, and then you take them to the testing facility and they crush that at 7 days, 14 days and 28 days to make sure it takes 28 megapascals of pressure to crush it, at 28 days, and that's a representation that the slab also has achieved 20 megapascals by 28 days. And then you start building the walls. So you're supposed to wait until you get the final yes before you keep building. There's a little bit of rushing sometimes on site.
He tells us, they're getting pumped out like every 4 months.
So there's a lot of confidence in our batching plants here. But if it's found at that compaction test at 28 days that the compaction isn't achieved, they technically should rip everything up and start again. Yeah. No, thankfully. But I'm sure it has happened.
On big multi-story buildings,
Yes.
you certainly will be waiting your 28 days
Yeah.
before you build the next floor above that again.
Residential, not so much. And for
But
carpet slabs.
slab on ground for dwelling houses, not so much, yeah.
yeah.
Also, if you want to have an exposed aggregate floor, you've got to tell the batch plant beforehand so they can not use the blue metal, but the stone, so you get all the colours in there.
There's all sorts of different exposed aggregate that you can ask for. Yeah, they're painful to walk on. I'm not a fan of exposed aggregate. I don't mind Pebblecrete, but...
Not if you blast it out, because there's different styles in it. But if you're just going to cut the top off so it's sort of like this, and then it's...
So polished concrete's not the same as exposed aggregate. So if this was my concrete slab, and I was just going to take, and I would build it up, this is, don't worry about the walls, you would do this now. I would just take a few mil off and polish it, then that would be exposing, you would be able to see, and the idea is that then that's your finish. It's tricky to get slabs to be crack-free. You'll often get little capillary cracks, and sometimes when you do that polishing, you can get a bit of aggregate that's really clumped together too much, and there's not enough cement to bind it, and it becomes loose, and you end up with a hole in your floor and things. So there is a risk. You have to know what you're doing. When you want a polished slab, you've got to negotiate extra money typically for that. If you want an external exposed aggregate, you pour it as normal, but you put a sugar syrup mixture down on the wet concrete for a couple of minutes, maybe 15 minutes, as it's poured. So you screed it, you make it all flat, looks real nice, and then you just spray like a sugar water over the top. You could just use like a weed sprayer. It's very light and gentle. It just stops the top few millimeters from going off. Curing, that's the way we call it, going off. And then you blast that off, and it leaves you with the aggregate exposed, half the rocks at the top exposed aggregate. Yeah, it's going out of vogue, I must admit, and it's not particularly pleasant to walk on. But the other option is, rather than that, is to keep the normal concrete, don't worry about the sugar, and put Pebblecrete down and press that in and then seal it. So the top layer you might put a small, because the rest it's expensive, the little stones, they're nice and round and they're beautiful, but you don't do all the aggregate with that because that's too expensive. So you might just do a top section in Pebblecrete and then seal that. And that's, you can't see any concrete then, it's all the little pebbles, and they're quite nice as well. Pardon? Yes, pure aesthetics, correct. Both the aggregate and the Pebblecrete are both pure aesthetics. But you can just use a broom and make a broom finish if you want like a non-slip texture that's low expense, not particularly pleasant, but you can do it. You can just screed it, you can do the sponge, yep, there's all sorts of finishes to the raw concrete that you can do. Water must not be added to the mix to increase the slump to a value in excess of that specified, so the engineer will be involved in all of that. And the concrete must be placed, compacted and cured in accordance with good building practice. Vague, isn't it?
I always think of concrete as a bit like making a cake. It's got the ingredients, you've got to get the ratios right, or your cake won't turn out quite as it should do, and it's got to cure, it's got to cook, it's got to have that period of time to let it.
You don't want it to fall flat.
Yes, you don't want it to fail in that process either.
What a ridiculous thing for a legally binding document.
Good building practice, yeah. That's about making sure that the concrete gets into all the places it's supposed to.
Yeah.
Well, let's say concrete. Do it properly.
Yeah. So that's a T-shirt in that. Concrete, do it properly.
End of every chapter, like they could write that on every chapter. Of course, we're supposed to do it in the building practice, all of it.
So please don't Stake me if I've got this at all incorrect, but I'm fairly, like 99% confident this is correct. I shouldn't quote maths without pre-checking because it is not my strength, but I'm fairly confident this is correct. So MPa, I do know, stands for megapascals. So pascals is about pressure. Has anybody heard of kilopascals or pressure pascals on the weather? So we get, you know, different pressure systems and they call them in pascals, megapascals. So 1 pascal is a very small unit, roughly the equivalent of the pressure of 1 kilogram over a square metre. So that's not very much pressure. And in building, we don't have anything with that little pressure. We talk in megapascals straight away. So a mega is 1,000 times more. 1,000? 10,000 now, I'm not sure, because kilo is 1,000. Oh, there, I knew there was something. So I think it's actually, might be 10,000. There you go. One boo-boo. That's not too bad. Off the top of my head. Yeah. So if 1 pascal is a kilogram over a square metre, a megapascal is 10,000 kilograms over a square metre. So 20 megapascals will be 20,000. 200,000 kilograms over a square metre. That doesn't seem right. That doesn't sound right. I shouldn't do maths in my head. I apologise.
No, 20 by 10,000 is going to be 200. Yep. You were right.
I was right? Oh gosh, I shouldn't doubt myself. Okay. Yeah.
Will this test have to take place?
As far as I'm aware,
Specify the concrete.
Set up in the world, but the slum test is always done at the batching plant. Always. They keep a record at the batching plant. Of
and they have a testing there.
Shipment that goes out there, they would do a slum test there. But you're kind of asking the manufacturer to do their own testing at that point. You're relying on them to do their own testing. However, it's like any other building product, and you know, if a builder has an issue with your concrete that you've supplied them on this house, he's not going to buy the concrete from you anymore. So it's up to the manufacturers then, of course, to regulate their own quality, and they don't want to be letting their builders down. That's their customers. So yeah, you can be assured that their quality is reasonably good.
I haven't heard of any issues.
No, me either.
It's going to be tested.
Pardon?
It's going to have to be tested twice, one at the factory and one at the thing, because given the time that it travels,
it's not typically, but
it's not always done on site. It is on larger jobs, but not for domestic housing.
Yeah. What were you saying, Josh?
No.
The project monitors it, yes, but the drafters don't. But we do specify it on the drawings.
So the site manager could be the person to manage that. And also for the specification of the strength of concrete and all of that, that lies with the structural engineer, not with the draft person.
3.2.3.2, steel reinforcement. Materials used for reinforcing steel must comply with AS 2870 and be welded wire reinforcing fabric or trench mesh or steel reinforcing bars. These are all good phrases to lock into your memory. Reinforcing fabric, so that's the big mesh, it's just a big grid of reinforcing. Or trench mesh, which is similar but in a long strip that goes in the bottom of a trench. Or reinforcing bars that just come in strips of their own. Now we have some samples of a few of these over here. Here's one I prepared earlier. What have we got here? Oh, goodness me. So one of my past students very kindly sourced these samples for us. So don't lose them. There's reinforcing samples and the diameters written in texture on the ends. So you can have a bit of a look. And you'll notice they have a texture to them, and it just creates a little surface tension and resistance against being able to reef it out and pull it through. Don't have any trench mesh, do we? I thought we had some fabric. That's all right. Somebody will give us one. Kizzy, can you get us some fabric? You reckon? A couple of squares? 100 by 100? Maybe? 72? 72? So the other thing that you'll observe that we use reinforcing for, it isn't just inside the slab, but remember the chain of strength? And we talked about how everything has to be connected. So the wall has to be connected to the slab. So this is kind of an addition to what we're talking about in the NCC. You won't see this in the NCC. So we have a couple of ways of connecting walls to slabs as part of the hold down chain of strength. One way is to have something like this, which is threaded rod. So when I pass this around, you'll see it's got thread all the way over it. This gets embedded into the footing and sticks up out of the slab. And then the steel framing gets connected to it with washers and bolts. That's why it's threaded. So then this becomes the connection between the wall framing and the slab for steel framing. The hold down rod is for the timber. So it's like this, but much longer. It's a bit trickier to build, but you can put it in as the framing is finished. So it's not sticking up on its own, waving around. If you have very long reinforcing, it looks a bit dangerous. It's not very good, whereas something like this, it just sticks up and you could put a little plastic cap on the top so nobody impales their foot on it while you wait for the walling to be finished. This one is for block work. Now, it's not completely finished, but it'll give you a bit of an idea. And this is what is colloquially known as a starter bar. So similar concept to the threaded rod for steel framing. This bit sits inside the footing and then it sticks up. Now, it's not as long as it ought to be, but it looks very similar to what it's supposed to be. It needs to be at least 600 millimetres tall. And then you put more reinforcing in the blockwork wall as you're building it. But again, you can't put this reinforcing in the footing and then have it to be the full 2.7 metres high while you wait for the blockwork to be threaded over it as you build it. That would be a little absurd. So in construction, it just doesn't work that way. Ideally, what we'd like is a single piece from the floor up through the wall and to the roof, but that's not practical, like I just said. So we do the start of it, which is why it's called the starter bar, and it's turned over so it's not dangerous. So this one might stay in place for a little while, but it's not very tall, and it's not too bad. You can put a safety cap over that, and it's not going to bother anybody while you build the steel wall construction over the top of it. But this one's a bit taller, and there's a lot of them. Same rules as the timber. Every corner adjacent to every opening and 900 centres in between. There can be a lot of them, and they can be quite sharp. So you bend them over, or you put a plastic cap over the top of it as well. You can thread 3 courses of blocks over that. It's not too bad. And then by the time you get to the top of 3 courses, because it's 200, 200, 200, you've reached the top of your 600 height for the starter bar. You can finish building the walls, and then you pop the rest of the reinforcing down inside the blockwork before you finish the construction. And then you fill that core with concrete. Every corner adjacent to every opening and 900 centres in between.
Usually we slash a hole in the bottom of the wall to allow walls they don't fall apart.
Yes, quite right. So this one's sticking up out of the slab. It's taller, like I said, 600. Then we put the blockwork over the top, and then we put the other reinforcing all the way down so that it overlaps. The new reinforcing that comes down has to go all the way to the bottom of the wall, to the top of the slab. And like Kizzy said, you punch a hole in the bottom of the blockwork, they call it a mouse hole, so that you can visually inspect that the reinforcing gets all the way to the bottom. Then you use a bit of wire to put a cap over that. You fill it with pretty wet concrete, not too wet because it still has to be 20 MPa, but wet enough so that the aggregate can get in and around what is bits of mortar in between the blocks, and there's some reinforcing in there. It's a bit more difficult for the aggregate and things to get in. You might have to vibrate, make the aggregate smaller and vibrate it down, but not too much vibration because you don't want the water and the cement and the rocks to all separate, because too much vibration will do that. That'll come up in your research. And then you wait for that to cure, and then you take the lid off the mouse hole and make sure the reinforcement is fully encased in concrete, so that that core fill reinforcing is fully encased in concrete. It's got all the way to the bottom of that core. So then the 2 pieces of reinforcing that overlap one another are one piece now inside that reinforced concrete.
Stay connected to just wire.
You can tie them together a little bit in wire, just to help them stay together if you want to, but it's not too big a drama. And then the long one usually sticks out a little bit, and that's what connects to the over bracket that goes with the trusses. There'll be other reinforcing in the horizontal plane, directly above the doors and windows, and then directly underneath the trusses, but we'll come to that when we cover walls. I just wanted to mention how walls are connected to slabs here locally. Hold down chain of strength. I miss anything, Sandra? Nope, good. Okay, so I'll pass these around so you can have a bit of a play. Try not to get tetanus. Hey? Yeah, too late. Does anybody have any questions about that? So if you're wandering around new subdivisions and you see bits of wire sticking out of slabs, that's what that is. Candy canes.
A long time ago, I went to Egypt and it was a huge bus journey to get to Cairo from the port we were at.
Yeah.
And on the way, you know, every single building was all built, but then it had lots of reinforcing out the roof. Every single building in the whole. I couldn't understand this. So eventually the tour guide explained why. I said, seemingly in Egypt, you don't pay the government the whatever taxes owed on
stamp duty.
On your stamp duty on your building
until
it's complete. So they never completed any building. They let every building had the top floor left off and all the reinforcing out of the top floor.
So how many other countries do you think have the same rule? Mexico,
right.
India. There's lots of Asian countries that have the same thing.
Yeah.
It's everywhere. Yep. And it might be in that cliff as well. Yeah, you're right. It's a good solution. There could always be another story. You just never know. Oh, sorry, they're all coming to you, Justina. Okay, have they come through? No, keep coming. Yeah, build a house. This way hasn't come through. Yep. So Nicole, have you seen them? Yep. Just keep passing them on. All right. So we talked about that steel reinforcing bars. What I just talked about, that falls under this category here. Steel reinforcing bars. Now the other place that you'll see steel reinforcing bars is if you have a beam and you have to have long reinforcing inside that concrete beam. So it might be 4 pieces and you'll use wire tags to hold it in place. That's fine, looks great. Anyway, you can find a pot. So if you've got some block work and you have to hold some reinforcing somewhere in the middle of nowhere, you can have these little tags. These are also wall tags for other things like doors and windows, but they'll also take reinforcing and just hold them in place, which can be quite handy. I've got them. Kind of. Oh. So they sit in there. That's probably a bad example. Okay. Oh, not enough. Alright. So this reinforcing fabric is big sections of steel that's made into a mesh, like a big crisscross. So it can cover a huge area. And I did a quick Google while you were on the break just to see if I could find one that I thought would show the picture. And as soon as I Googled concrete slab preparation, I found oodles and oodles of images with this crisscrossing. See all this crisscross here? Not this main crisscross, that's different, but these crisscrosses here and the little dots, those are the chairs holding that fabric up off the ground. They call it a fabric because it's just a crisscross like a stitch might be. And you can get them at different strengths and different widths apart. So depending on the purpose of the slab determines the size of the squares between the fabric crisscross. There's a table for all of that coming up. Again, engineers. Yep, engineers problem, that one.
There is one slab that I've seen before that has no mesh whatsoever.
Oh yeah?
It's reinforced all the way around the whole lot. It's,
yeah.
Gateway Big W. And that slab has no mesh whatsoever. It's all done with a metal quad that they've added to.
Right.
Oh wow.
Additive in the mix.
That's nifty.
Yeah. Well, it's supposed to be a polished floor.
Yeah.
Right.
When they polished it, the metal came out.
Yeah, right.
Lifted out of the concrete.
Yep.
So they went and put a
Top slab.
top over.
Right. Wow. Isn't that interesting? No reinforcing. Wow. That's interesting. No. Yeah, quite right. Yeah, it's not too bad. Very interesting.
They often do worry with polished floors about the cover on the mesh. So when you put the mesh in, you have to achieve at least 30 mil of concrete over the mesh, and that's to stop the mesh rusting and deteriorating or any water penetration getting to it. It's got to be sealed into the concrete with at least 30 mil. So then if you turn around and you polish that and you take it down another 10 mil, you've reduced your cover. So yeah, maybe that was a reason for them to do it that way.
Mm-hmm.
Otherwise, they're little metal pieces. They're actually like a little wire, capital Y.
Right.
They're about, I don't know, 3 inches.
How flexible are they?
Very flexible.
Fairly flexible. Yeah, that's what I thought. They're like a fibre almost. Yeah.
And they're like 1.5 mil thick. Something like that. Very, very thin.
Here is exactly what Sandra's talking about. Footings and slabs on ground must have concrete cover between the outermost edge of the reinforcement, including ligatures and tie wire. So in very deep footings, you might have what's called a ligature. It's just a big O of reinforcing. It's that starter bar reinforcing twisted into what is essentially a rectangle, and it just hangs from the fabric with a little wire tie and sits in the form of the edge beam, and then you put the trench mesh in underneath. So it's quite a bit of reinforcement, and you have those determined by the engineer at certain spacings along the edge beam. So they're saying beyond all of that, there's a minimum coverage. So 40 millimetres to unprotected ground, 30 millimetres to the membrane in connection with the ground, so that's the typical one that you'll see, and 20 mil to any internal surface, and 40 mil to any external exposure. So it's just making sure that there's enough concrete between the outside and the reinforcing, so water penetration, because like we said, concrete is porous. It's slowly porous, but it is porous nonetheless. So water can penetrate, and obviously water and steel creates rust. Rust is expansive, it pushes out, and it'll push your concrete out and ruin it. So that's spalling, S-P-A-L-L-I-N-G. Put that in your report. So concrete spalling is bad, loses all structure. And that was the reason why they demolished the Darwin Hotel, apparently. Too much concrete cancer. So reinforcement used must be cleaned of loose rust, mud, paints and oils immediately prior to the concrete pour. Most people just buy new mesh. They don't use recycled very often. I did hear a story that apparently the refurbishing of Darwin during Cyclone Tracy was so fast and so hard to keep up with. Teams who were pouring concrete had time. The inspector would come along, see the prep, say, yep, pour, and go to the next, and they would pick the reinforcing up, take it to the next site, and then use it for the next inspection. So there could be quite a few slabs out there that don't actually have the mesh in them they're supposed to. They'd be 40 years old now, so it's, you know, it'd be obvious if it was already done, but it's a good story. All reinforcement must be firmly fixed in place to prevent it moving during concreting operations. Reinforcement must be supported off the ground or the forms by bar chairs made from wire, concrete or plastic. And it was already floating around those chairs. You just get them in a big bag and hook them under the different intersections. So you probably saw that. Pardon? Aren't they? Yeah. Yeah, they would go through the plastic. The plastic ones are good, the little round one that I had. When using wire chairs, the minimum concrete cover to the uncoated portion of the chair must be obtained. Wire chairs on soft ground or plastic membrane must be placed on flat bases. Bar chairs must be spaced at not more than 800 millimetre centres for steel fabric. So if I go back to that image that I was showing you, you can see them all placed around, and they're saying no more than 800 millimetres apart.
The houses in Indonesia, especially my aunties and my mum probably, they don't put a membrane on the
Okay.
door. So to compensate that, they just make it a thicker slab.
Sure.
So bad.
That seems like a bit of a waste of concrete when you could just use the plastic. If the plastic is hard to come by, I can understand.
Yeah, you can't get plastic over there. But
Yep.
yeah, they just put a thicker slab.
Yep.
But then the ratio, the MPA is not like just that.
No, it's
And they think
usually
more
weaker.
If they put more concrete, it's going to be more stronger. It's like,
Yeah.
no, it doesn't work that way.
Remember I said the other day, concrete never stops hardening? If you wait long enough, you'll achieve the required thickness. 28 days to get MPA, 20 MPA is the norm up here. If you have concrete that's come to you that isn't heavy enough, then you might need to just wait longer. Nobody's got time to wait around here, so we don't go that way. It's not typically how it's done, but yeah. There's all sorts of, I think in Mexico, a girl that I spoke to said they had to wait 6 months before they could build. Hey?
Talking about waiting for the concrete.
No, once it's poured.
So if it's not 28 days.
Yeah, don't quote me on that it will get strong enough, but it does continue to get hard, yes. It just keeps going off forever. So if you want to drill into a concrete wall early in its life, it'll be easier than much later in its life. Yeah, yeah.
I reckon the concrete they used in the Hoover Dam over there in America.
On the inside? Really? Wow. Well, the heat's got to get all the way to the outside. Yeah. So you'll find when you're doing your concrete research that it emits heat. And if it is allowed to emit that heat too fast or to heat up too far, then it will crack during the curing process. And it's the first sort of 28 to 48 hours that are the most urgent. You'll recognise that most concrete is poured in the dark here. Obviously, as soon as the sun comes up, it's too hot, particularly in the wet season. So we try and pour in the cool of the night. We will also keep it wet once it has gone off. It doesn't take long to go off on site, particularly here. It might only take a little while, maybe half an hour. And then you can't walk on it yet, but you can spray it with water, and that will keep it cool while it continues to cure over the first 28 days, first 24 hours, 48 hours. So some teams will build a little moat around the top of the slab with some sand and use it like a swimming pool and fill it up. Others will just stand and hose it, and others will put those sprinklers, you know, those sprinkler hoses. They're just those long plastic hoses with a little bit of water that comes out. They'll lower a few of those around. It just depends on what their preferred option is. You've got to keep it cool for the first day, while that sun's out until the evening, and then it's not too bad.
Place called Paxhill, just north of Broken Hill.
Yep.
Laying some concrete slabs, and they had the hoses out, those little trickle hoses to keep it cool.
Oh, yeah?
Which is fine to attract all the cows, so when the cows came through and smacked through all the...
Oh no.
But that comes before, definitely.
Wow. That's so uncool. I have never heard of something like that happening before. That's a brilliant story.
Oh, I don't know. I was there for a few
You must
months.
have reported. And put a fence around it.
Got my dad's slab, I didn't care.
Oh, they put a
all
temporary
the
fencing.
reinforcing, all the mesh would have been just
Yeah,
crumpled.
they should have put a temporary fencing.
Yeah.
Metromed does do a big week. It was just one continual pour work in 2 days.
So what's that?
No, mattress.
Yeah, wow. It's crazy.
How many trucks were coming in and out?
Just constant, yeah.
They just kept on board.
So crazy. Clause 3.2.5.3 is about shrinkage control. So materials expand and contract, and concrete is no different. So we have to have just a little bit of an appreciation that that's the case, and the bigger the expanse, the more the movement is going to be. So this is where brittle floor coverings, such as ceramic tiles, are to be used over an area greater than 16 square metres. One of the following additional measures must be taken to control the effect of shrinkage cracking. So the amount of reinforcement must be increased to this. SL92 is the weight and the spacing of that fabric. So you can increase the strength of that to help resist that shrinkage, the concrete shrinkage. Or you can, it says doubled with an additional sheet of slab mesh throughout the affected slab area. So you can have 2 rows, which is a 2-way slab, some reinforcing at the bottom and some reinforcing at the top, much bigger slab. So that might be for multi-storey residential apartments where you need the structural steel for both the span, and then you've got also that shrinkage control as well. A bedding system for brittle coverings must be selected on the basis, so the glue that you use, it must be selected on the basis of the expected slab movement and the characteristics of the floor covering. So flexible glue, flexible-ish grout. We're not talking like jelly, but just within a certain limit. Not like my neighbours, but people who have a fairly stable slab. The placement of floor covering must be delayed for not less than 3 months after the concrete has been poured. Oh, that's a long time. I don't know whether that actually happens as much as it perhaps should.
I once did a job, it was overseas actually, it was in Timor, and they were so concerned about there was lots of expansion joints in the concrete slab, and so we were doing a tiling layout, and we did the tiling layout to work in with the expansion joints, so we could leave the expansion joints in the tiles as well. So that's where it becomes quite architectural, because if you've got expansion joints in the slab, and you tile straight over the top of them, what do you think is going to happen to the tiles?
Yeah. Pop! So an expansion joint, just very briefly, is where you make an indentation in the concrete. So you're actually cutting it. So this is my slab, 100 mil thick, and I've got my reinforcing, and we just cut it, we just depress this. It's not well drawn, apologies. Don't cut the reinforcing, just the concrete. Depress the fabric in that location so that you can have a concrete cut. I think it's 40 mil. Expansion joint or construction joint every 5 or 6 metres. Now, if you're wandering around footpaths now, you'll be aware every time you're walking, you know, don't step on the cracks, break your mother's back if you heard that. That's an expansion joint in the footpath. But sometimes you'll have those, and then you'll notice a crack just goes off in a different direction. So what that means is the expansion joint was in the right place, and the concrete's gone ahead and expanded in a different location.
Well, there must be like a root growing underneath there.
Could be, yeah, it could be movement, could be, you know, it could be straight after it was poured, it could be later, who knows. But that's what those lines in the paving are, expansion joints. Yeah, every 10 metres, you cut. In a big blockwork wall like that, 10 metres is about the limit you can get, and then the expansion and contraction gets so great that it moves too much at the ends. It's an additive. It just keeps moving and moving and moving, and then you get a crack where you don't want it. So you cut it every 10 metres approximately, but if you reach 8 metres and there happens to be a door there, you'd only have to cut the blockwork above the door, so you would do it there. So within 10 metres roughly. And then you put movable silicon in there. You don't just leave a gap, because then you've got water penetration and all sorts of other issues, vermin and what have you. So then you fill it with silicon.
With the wet concrete, after the 28 days, it's got a bit of a shrinkage, doesn't it?
Yeah,
The water
a little bit.
evaporates.
Yep. So that's the shrinkage that they're talking about. So just wait until that settles down before you start tiling over the top. So an extra bit here is at re-entrant or internal corners, 2 strips, a minimum of 2 metres in length of L3, L8 trench mesh, or 1 strip of 3, L11 trench mesh must be placed diagonally across the corner in accordance. So I just read that out, it probably won't mean anything to you. Re-entrant bars are a way to stop some of that cracking. So this is a really good diagram. We've got our floor plan outline, and where the corners come in, they're re-entrant corners. Cracking is very common from there. So you don't want slab cracking here or here, so you'll put 12 mil reinforcing for a couple of metres long, see 2 metres, and you put 1 here, and typically in Darwin we put two re-entrant bars across the slab there. It just helps prevent that cracking during shrinkage. So it normally will sit on top of the mesh and just get wired in place, just little wire tags. Still with the coverage and everything, but just extra bars to hold that corner in place where it re-enters the floor plan. Yeah. Yeah, that's right.
In your previous job, it's like, oh,
And, like the trench mesh,
yeah.
use that.
Fireplaces, no, we're not going to be talking about fireplaces. Minimum edge beam dimensions.
Sell them in Bunnings and places.
Yeah. They set it down on until they, it might be fancy.
Stump footings, stumps, yeah. So here, there's some minimum dimensions for all sorts of different things here. I'm scooting past them a little bit. One, because we do have engineered alternative solutions for our sites up here, and this won't really apply specifically, but there's some diagrams that I'd rather look at. I really just want to show you the different shapes and sizes of the different footings that you can have. So I'm just skipping past tables and standards. I've already mentioned the standards a couple of times already. All right. If in doubt, these sizes are a good place to start if you need an idea of where to start with your footing size, and then the engineer would give you markups to either increase or decrease from there. It's often wise to give them the minimum and let them go up from there, because if you give them the more, they're not likely to go down. I'll just leave it the way it is. So I'm fairly conservative with my guesstimations of what a footing size might need to be before I send it to the engineer, and then I make them build it up higher if they have to. So we've got pad footings for clad frame and Class A and S sites. Pad footings are just a big square cube. Don't see them very often here. We have pier footings that are round and long and thin, and we have beam footings that will go around the perimeter of a slab, but we don't see pad footings very often here. But pad footings are excellent if you've got a bit of movement in your site because it'll stay steady. And we often get people digging their own stump footings, and they'll end up building something like this instead of the long, thin, round pier footings, just because this is easier to dig. So they have to go a lot further down because typically it's about reaching firm natural ground before they stop digging. But pad footings do exist. They're a thing. It's for particularly wide columns, a good way to have a footing for that to sit on. So when we're talking multi-storey apartments or multi-storey car parks where you've got very wide columns supporting a significant amount of weight, then you've got a big flat pad footing for it to go in. If you think about the difference between a point load, say you standing on ice, there's all the load of you standing on a very small space. So a pad footing where you lay on the ice spreads that centre of gravity out and it doesn't go down as fast. So a pad footing is good for a little bit of unstable soil or for where you've got significant loads and you don't want to have too fine a point for them to come down to. And a pad spreads the load out really nicely. So that's a pad footing. And you simply just specify the square meterage, the width, if it's circular, and its thickness and depth, if it's circular. So it's just a big square. You can see they've got stumps and piers. And what you won't see in the NCC is what we call pier footings. So our columns are going to go into pier footings. So I'm going to have to digress here a little bit from the NCC because, like I said, this is an alternative solution. Pier footings, so here we've got our thickened edge. The other footing that we are going to be specifying in our report are pier footings to take our columns. So they are typically circular, simply because the machine that digs the holes has an auger, a drill, that's circular. So that's how they end up. If it was square, they'd be square, but it's not because it's easier to dig it out. So the auger comes in different diameters, and the engineers will specify the diameter of the pier footing. It starts from anywhere down as narrow as 450 millimetres. It might go up to 600 millimetres, or it might be as wide as 900 millimetres, or even greater. They're the most common for a residential the size of ours. So that's the diameter of the hole that the concrete will go in to support the column above ground for our elevated house. So we're doing either 450, 600 or 900. Bored, not bored as in I'm going to sleep because class is boring. Bored as in I've bored a hole in the earth. Bored, pier, footing. So here's my circle and it's literally just a big hole. The depth is determined by the engineer and the soil classification. You have to keep digging until you've reached firm natural ground. So we have no clue how deep they'll need to be. So here, these are our piers. The NCC says put a pad footing underneath that, not for us. So our flood inundated site and our soil classification says this is the ideal solution. Yeah. There you go. Now, chain of strength says we have to connect whatever's above ground to below ground. This is below ground. This is what we've got below ground on our laundry footing and our carport slab footing. For our columns, the main house, this is our ground. So if ground is here, we've got to have a way to connect everything above ground to what's in the firm natural ground connection that we've just dug. And there'll be one under every single column that we've got, even if it's not structural, like a little short one underneath the stairs. That's still structural, but you get the idea. So there are a couple of different ways that you can do this. Now we were talking about having 100 by 100 SHS columns as our elevated legs, if you like, our stilts. We could actually put that same steel into the ground. I don't recommend doing the whole 3 metres plus what's in the ground at the same time, because holding that straight while you wait for the concrete to cure for 28 days might be a little bit tricky. So perhaps we might do what's in the ground first and then do what's out of the ground second and connect them together with a welded plate. That's an option. So I'm doing partly 2D, partly 3D. I hope you're following along okay. So a very long piece of steel, the exact same steel as we're building our column out of, and then you have to put a plate on the bottom as well, and that has to be a minimum of 150 millimetres above the bottom of the hole. You've got to get concrete underneath, fully encase the steel to protect it from water and rust and all that sort of stuff, but put a plate on the bottom too, one that's bigger than the steel so that it helps stop it from being pulled out, highly unlikely, but just in case, but also to seal off the bottom of the concrete. And you would paint that in that black bituminous paint that waterproofs the outside of the steel. You don't want any water touching that steel. The concrete's full of water to make it plastic when we put it in the hole. So that's option one. So you put that stump in the hole, you hold it here with some bracing so it doesn't sink down the bottom, because you can't get in there to put a chair in there, that's not going to work. So it's just got to be hung from ground level so that it's a minimum of 150 above the bottom of the hole. The tricky part is getting that last bit of dirt out of the bottom of the footing. I think my dad dropped my son down with his feet and a dustpan and broom once for a joke. You just have to dig further. So you can sit that there, wait for that to cure, and then you weld the column above it before you put the bearer on top, before you bring the house in. So that's one way. The other way, similar concept, you build in advance. We're never going to be able to keep the full 3 metres plus whatever's in this hole straight to build it all in one go. I don't know of anybody that would ever do that. Too risky. The other option is, rather than a whole piece of steel, you simply use reinforcing. So still with the plate, because you've got to have something to weld the bottom of the column to, and it's going to be slightly larger than the column itself to give you some room to do the welding. So you've still got the plate, and that goes up to the column later. But here underneath, you have 4 big long pieces of reinforcing, that same stuff that we were passing around, and it goes all the way down to the bottom. Now, these long pieces of what looks like spaghetti are steel reinforcing. You don't let them just dangle like a mobile. You use, remember I said ligatures earlier? So you use more steel reinforcing to connect them together. So it's more of the same steel, and it's made in a loop, and it goes around the outside, and it's tied on with little wires. And the engineer determines how big the steel is and at what intervals those ligatures need to go in to make the cage that gets dropped down into the footing. And again, they are splayed at the bottom to create a cog, C-O-G, to create a cog so that it can't be pulled out under wind conditions. So you build that, it gets welded here underneath, it's welded to the bottom of the plate, reasonably sizable plate, good 8 or 10 mil thick, and then that sits just above the concrete, and then you can weld the column above that when you're ready. The concrete in this hole needs to be sloped to shed water. It just gets a slight slope on it so that if ever there's water, it goes away from the steel, not sitting ponded on top of the steel. So when people place pavers and different gravels and things, it's really important that you maintain that. And if you wander around the campus even easily enough, you can see where pavers have a dip towards a column and there's rust at the bottom of that column. Yeah.
So would you weld the plate after?
It's part of the steel before it gets dropped in. Yeah, the plate's part of that, holds it all together at the top. Yeah.
That weld is above finished round.
Normally the plate and the concrete are right at the top. So you just see the plate and then the shedded concrete to the top of the footing. Yeah, you don't sort of see the reinforcing sticking up too much. In other instances where you want to connect that with a bolt, you can actually come up through the plate and then bring another member on top and have, like for portal frame sheds and things like that, but in this instance you're just welding. Yeah. Does anybody have any questions about it? It's quite unique and special to us. Very effective, good for lightweight construction, because you don't have too much load pushing down in that point. That's a point load that's going to sink if you're not careful. But for lightweight construction, it's very inexpensive. It doesn't get in the way. It just is the bare minimum that you need underneath the structural work that you've got. No mess, no fuss. Cool. How are we doing for time? Not too bad. So a couple more footing types to just make you aware of. Pads we've done, pier footings we've done. Footing slab and stiffened raft slab. So a stiffened raft slab. We've got this, we've said the word thickened edge slab or edge beam quite a few times. To give you a bit of perspective, because what I've drawn there is just a small part of it, to give you a bit of a bigger picture of, oh sorry if I rubbed that out too quickly, apologies, I can draw it again anytime. If you've got a laundry, which is what we've got, it's a square. So this is the floor of my laundry where the tiles go and you stand inside. This is what I can see of the edge. Now it'll be determined by the engineer how deep the beam needs to be. Let's say 350 millimetres for argument's sake. So this is 350 millimetres deep. But the floor is not 350 millimetres deep. The bit where you walk around in the middle, it doesn't need to be 350 millimetres deep. That's too much. It might only be 100 millimetres deep. And we've talked already about the fact that we pour both the slab and the edge beam at the same time. So you saw that shape in section, and this is simply just because it's hard to get an exact right angle with that compressed sand. So you just get this little chamfer here, because if you tried to keep the sand exactly like this, it would break away like a sandcastle might, and it'll end up making a big mess of things. So you simply just account for that and make it this way. That's all that is. So this is my 350, for example, or let's say 450 in total. The top of it is the floor slab and the bottom part is the beam. But you can see the floor slab is for the majority and it comes down over the other side. So if this is my continuation, then it comes down over the other side in section. If I was to draw a section through here, that's what it would look like. But in the middle, it's only 100 mil thick. So we've got this tube, if you like, that goes all the way around the perimeter. Do you see that? Yeah, like an upside down kids pool. Quite right. So there's an extra thickened edge that goes through the entire perimeter. And then the bit in the middle is the floor slab. It's typically 100 mil thick, and for want of a better example, the rest is 350. And there's enough room in there for the fabric to sit up here with a minimum 30 cover. There's your reinforcing, and you might have a ligature hanging there, which is your steel reinforcing, and you might have some trench mesh in the bottom held up by a couple of chairs. So then all your reinforcing is in there, both for the floor and the footing, and you fill the whole thing with concrete all in one go. Then you don't have to worry about movement and separation, and it's all quite well done. That's a typical thickened edge slab, perfect for a Class S site here in Darwin, where the ground, or an A, where the ground movement is quite stable. Because the tricky part is, if the movement, like my poor neighbours, is different, this part is weaker than this part. So if you get movement in the middle, the slab will go up, separately or more than the thickened edge. It'll get a bit of flexibility in there, which you don't want. That's where all doors and windows don't open and tiles crack and walls crack and it's all a big mess. So my neighbour has a 5 millimetre difference between the centre of the floor and the outside of the floor. That's a lot. Because most doors and windows don't even have 5 mm clearance. You don't want, we talked about thermal energy efficiency yesterday, you don't want to be able to see through. 5 millimetres is a lot. So as soon as you get that amount of difference from the beginning of the end of a slab, then you've got problems with construction. So if you've got the kind of site that is likely to move, you want the whole thing to move together, not differently. To achieve that, you use a stiffened raft slab. It looks like a breakfast waffle. It has these kinds of sections crisscrossed through the whole slab. And it looks like a waffle slab, a raft slab, like you've got a crisscross of support. If that's the case, which is a little bit more expensive, then it will go up and down the way it's supposed to. And in section, it looks more like this. Something like that.
And that's what we require for a site.
That would be for a problematic site if we had a big, heavy construction house on non-SA sites. Yeah, so not our problem right now, but something to be aware of for the future. So it's rigid and it all moves together. We're not dealing with worry too much with the laundry. I think we'll be okay with the thickened edge. You could perhaps advise that maybe considering a raft slab for the laundry. For concrete slab portable homes, that's the slab they use. Because you can pick a concrete slab up with a house on top of it and move it from one place to another. But if you want to be able to do that, you have to use one of these slabs. The other one wouldn't last, wouldn't hold when you picked it up. So they put big holes in the form work, big holes, and the reinforcing is accounted for and the concrete is bigger because of it, and then you can thread the lift through there on each side and pick it up. Yeah, just throw that in there. So a raft slab or a waffle slab? Floats like a raft. I don't think you'll see waffle in the NCC, it's raft slab. It did that? Oh, blow me down. The other thing I want to point out to you is this internal beam here. Now on the drawings that I pulled up on the internet, there are all these big, deep holes. See these here? This one happens to be in a nice, neat grid, but that's not always the case. That's more for a commercial premises than a residential one. They're big holes in the foundation, and they'll have ligatures and trench mesh in them just the same as the edge beam. They're just lovely when they're grid like that, but that's not typical for residential. An internal beam is where you have an internal load-bearing wall, and it has to have a beam to sit on. An internal load-bearing wall can't sit on a 100 mil thick slab and do its job. The load would then push that slab down, and you would get settlement that was uneven in the wrong direction, downwards instead of upwards, like we were talking about with moisture and movement pushing it up. So if you have an internal load-bearing wall, you have to add a beam underneath it. So you'll still get your ligature and your trench mesh, but it'll generally be halfway through the building. So if I was to take away my waffle slab idea and add my internal beam, it might be here. So rather than a waffle slab, we're just adding an additional beam here. And it's open and it takes concrete inside it. So the damp-proof membrane has to follow it, careful, and the chairs have to go in there and hold the trench mesh, and you have the sand protection still and everything, but it's an additional beam internally, and it would join up with the other one. So you would end up with, just getting a little out of hand, you would end up with 2 squares on your single rectangular building where the slab would sit. So then there's a beam right round underneath here. The slab would still sit over the whole thing in the end, but the beam would be like an 8. So you get the whole round and a bit in the middle, and you build your wall on top of that.
That's not traditional for those stick frames that use a metal internal structure, though, is it?
I couldn't tell you.
They should have a,
You're saying framed?
yeah, the
That's
framed ones.
yeah, that's a little different. I mean, load-bearing framed walls still have to have a beam underneath them, but it might be a double floor joist or it might be concrete. It just depends on what the construction is, case by case. But don't get me started about kit homes. All right, so we've got internal beams, external beams, and reinforcing and ligatures and trench mesh through the lot, and then you pour the concrete over the whole thing. So that's what, that's what it shows in section for an internal beam. See, on the edge beam, it's a straight edge on one side and the chamfer for the sand on the inside. This one has chamfer for sand on both sides because there's no outer edge. Does anybody have any questions about all of that? A lot to take in. Now here's the minimum recommendations for the size of the trench mesh, the size of the fabric, and the depth of the footings for different site classes and different walling. So it's a good little matrix, but like I said, it's the minimum. So we would give that to an engineer and say, this is what we think the minimum should be. Do your magic and let me know if it has to be any greater. And remember, it has to pop out of the ground, that minimum site drainage clearance. Excuse me. A minimum of how far? 100 mil. And it has to have at least 150 in firm natural ground. A minimum of 150 millimetres in firm natural ground. Now you won't see that in the NCC necessarily because that's a hold down issue. That's about connecting to the ground to maintain our chain of strength into the ground. So our pier footing, even though it's going to be significantly deeper than that, needs to be a minimum of 150 millimetres into firm natural ground. So if you're digging down and it's sand and sand and sand and sand and sand, you've got to keep going until you hit firm natural ground, clay or rock, and then go down some more. Minimum of 150. Doesn't seem like much, but it's enough when you've got the weight of the house as well. So most pier footings go down 1 metre as average. If you've got a good site, 1 metre is normally long enough. If it's taller, if you've got more uplift, the footings have to go further down. So a big 4 metre high portal frame shed that's just roof, like a big kite that wants to be carried away, you might be looking at 2.5 metres deep for the footing because the component of the uplift is much greater, so the hold down has to be comparably greater as well. You guys have done so well. Is it just me or has it gotten a little warm in here? It's like the air conditioning has quit on us. It's hard enough to keep this awake as it is without the heat putting you to sleep. Different site classes, so the matrix continues. There's some suggested minimum dimensions, different classes, but all for the different types of construction techniques. So clad, articulated masonry, masonry veneer, articulated full masonry, and full masonry. So you can click on the links and have a look on what that means. So articulated masonry meaning masonry construction in which special provisions have been made for movement by articulation. I would argue that we have articulated masonry. Oh no, that's not what I wanted. That's what I wanted. Let's just see if there's anything left. Oops, go away. We should be awfully close to the edge. There's some other diagrams about raised slabs. Feel free to have a bit of a look at that. Strip footings. So strip footings are just the footing, no floor slab, separate. And they've got a diagram here where this is built up with soil and you've got the slab higher, but the walls are down to strip footings. I would recommend that perhaps our wall at the end of the entertainment area will have a strip footing underneath it. And then the entertainment area slab and the carport slab could be poured separately. So you've got laundry, carport and entertainment area. There'll be some construction joints every 5 or 6 metres, and then the edge beam underneath the blockwork wall at the end. Strip footing. Shouldn't say edge beam because it's not an edge. Yeah, that's enough of that. Good job, everybody. When you do end up reading the textbook, it'll start to make a bit more sense. We just have these extra things we like to do here. But when there's a real cyclone like we had earlier this year, everybody's very grateful. Does anybody have any more questions? The mowing strip's 50 mil thick, always. It's not structural, it's just a footpath. So 300 wide, 50 deep. Yeah, mowing strip.
We're going to have that on.
No, we're not going to have it on our design because the mowing strip is generally for slab-on-ground blockwork construction or slab-on-ground timber frame construction, and we're elevated. So we'll have the carport slab and the laundry and the wall, and then up. So we don't have a mowing strip for our project this time. That was a lot to include in the report, but it's important stuff.
Well, we were supposed to be taking notes.
Don't worry, I've recorded it for you. This session's only an hour and a half, so it's not too bad to listen back on. I'm sorry.